Okay, so let's go ahead and graph the second quadratic, the second example. All right, y is equal to 2x squared minus 2x minus 24. You can, because the a value is not 1, we can multiply a times c, magic x, and then make the 3 terms become 4 terms, and then GCF. Or we can GCF right off and make it an easy a equal 1. So I'm going to GCF a 2. And so that will give me, if I take out that 2, it'll give me x squared minus x minus 12. And now I have a very simple b is negative 1, c is negative 12. Okay, so how do I get 12? 1 and 12, 2 and 6, 3 and 4. Okay, so from those pairs, which one when multiplied will give me a negative 12, but which one when added and subtracted will give me negative 1. Okay, 12 is negative. That tells me that one number is positive and one is negative. And again, it doesn't matter which goes where. Okay, because I have a positive and negative, I'm subtracting here. So 12 take away 1 is 11. 11 is not 1, so that's out. 6 take away 2 is 4. That is not 1. Take that out. 4 take away 4 take away 3 is 1. This is our winner. Okay, I want 4 to be negative. I want the leftover to be negative. So that means the bigger number is negative. So 4 is negative, 3 is positive, correct? Okay, so now these are our factors. Okay, so we have 2x plus 3, x minus 4, right? And that is y equal, and that is our factored form, correct? Okay, but I want you to solve. Remember, we're going to factor then graph. What did we do in the first one? We got into factored form, then I made the y equal to 0 so we could perform the zero product property, and then we went ahead and solved and got our roots, or zeros or intercepts, right? Okay, so if I let y equal 0 now, I'm going to zero product property, and you can multiply this in or you can just leave it out. It would come out the same actually. So equals 0, x is negative 3, and positive 4. Okay, so these are intercepts, our roots, our zeros, our solutions. That's the whole point to this exercise. Okay, remember our axis of symmetry or our vertex is going to land in between these two values. So when y is 0, let me go to my xy table. When y is 0, x is negative 3, and when y is 0, x is negative 3, and x is 4, right? Okay, so that halfway mark is where we have our axis of symmetry and our vertex. Okay, so go to your, oh, here it is, our x and y axes. Okay, so find negative 3. 1, 2, there's my negative 3. Find 4. 1, 2, 3, 4. Remember, how do we find this pink dashed vertical line, which is our axis of symmetry? You want equal distance. So remember, 2 was 1, 2, 3 units away. 1, 2, 3 units away. So here, count how many units they are apart. 1, 2, 3, 4, 5, 6, 7. We're going to end up with a decimal here, if that's okay with you. Okay, so what's half of 7? 3.5. So 1, 2, 3 and a half. So our vertex, our axis symmetry is going to land somewhere right here. Okay, so count here. 1, 2, 3 and a half. Okay, so now let's verify that with a Post-it, just different color paper. All right, this is, this is negative 3. This is positive 4. We're saying that our axis of symmetry is actually 3.5 units in and 3.5 units in. Okay, so count 1, 2, 3 and a half. 1, 2, 3 and a half. And so my axis of symmetry exists right. I just realized I didn't finish that one. Oh, I'll connect it after. right through there. So I'm going to remove this if I can with one arm. And my axis of symmetry is right through here. And so that is 3.5 units in, 3.5 units in. And so that is, right? That is symmetry, that is equal distance. Okay, whoops, I just rolled my fingers there, sorry. Okay, so that number right here is, I'm gonna write it right here. Actually, I'm gonna write it up top. So our axis of symmetry is at x equals 0.5. Okay, 0.5 is my vertex, my x component to my vertex, right? Remember, these two numbers are always the same. Just like here, they're always the same, right? There's my -1. Okay, so now that means my vertex is sitting somewhere along this axis of symmetry vertical dashed line. I don't know where it is. How do I find out where the exact location is? Take that x value, 1/2, substitute it into your original, and get your output value. Okay, I'm trying to figure out how to hold it. All right, so I'm going to let x equal 0.5, and my parabola is 2x squared minus 2x minus 24. Okay, so I'm going to go ahead and substitute it. Now, you can use your calculator. I just want to make sure I don't mess up. Okay, so if you were to use this calculator, because now you have a decimal and it's a little not as pretty. Okay, 2 parentheses 0.5 squared, right? Remember, don't forget about that little squared. It's very common for students to leave it out, even though I know you understand what you're supposed to be doing. You understand the entire concept. Okay, so if I plug in 0.5, I get, hit SD, right? Change that to a decimal, -24.5. -24.5. Right? Okay, we're going to plot that, but we are going to go by 2 units. So this will be -2, -4, -6, -8, -10, -12, -14, -16, -18, -20, right? 22, -24. This is -26, so -25 is here. So -24.5 is right here. So this would be -24.5, right? Because if I'm going by 2 units, -24, -25, -26, so it would be between the -24 and the -25, which is -24.5 here. Okay. This is my vertex, 0.5, -24.5. I know I'm challenging you with these decimals, but if you get it, I mean, you're just so ready for integrated math 3, okay? Okay, now, if you want another point, oh wait, I didn't plot -3, +4. I was so worried about getting the halfway, I didn't plot those. Okay, remember, those are points. Here's my vertex point. You can go ahead and try and get there. Let's find another point. Okay, so if this is where my vertex is, right? I mean, meaning sitting on this dash point, and we're here. Let's go for negative, was that 1.5? So what is that? -1 and 2. Okay. So let's try -1 and 2. And so these are equal distant, right? They're 1.5 units apart. So what I mean, this is -1 and this is 2, right? Because here's my axis of symmetry. 1/2 a unit, 1 full unit, that's 1.5 away. 1/2 a unit, 1 unit, so that's 1.5 units away. So -1 and +2 are equally distant from the axis of symmetry. They're 1.5 units away, right? 1.5, 1.5. Okay, so that means the output values will be equal. So -1, 2. So we just have to grab one of these to substitute. I'll grab the 2. All right, if I grab the 2, let x equal 2, I get y is equal to 2, 2 squared minus 2, 2 minus 24. And you can use a calculator or you can just, you know, solve it in your head. Okay, 2 squared is 4. 2 times 4 is 8. Minus 4 minus 24. Okay, 8 minus 4 is 4. 4 minus 24 is negative 20. Okay, so my output value is negative 20 when my input value is 2. So input 2, output negative 20. So here, what did I say, negative 20? I said enough times, I should have remembered. Okay, so negative 120 to negative 20. All right, so come back here. Negative 20 is here, so negative 120 to 20. And so there's my equal distance, right? It's 1.5 units away, 1.5 units away. And so now if you connect, and that way you get more precision, right? And most of your graphs look just absolutely gorgeous. I love them. I love looking at them. You make me smile when I see the colors and just how precise and organized it is. I just have to look at it and I can immediately grade it and see that it's gorgeous because I'm looking at the same assignment over and over, and so they're all the same, which it's so easy to grade and it's just beautiful. Okay, if this is a little confusing to you, I apologize. I hope it was clear. But remember, when you factor the two numbers that you find, plot them, and now what do? Find the halfway mark, and that's my pink dashed line. Find the halfway mark. That number then goes in your XY table. You have half your vertex. How do you find the Y value to your vertex? By substitution. Take that number, substitute it, and get your output value. And your output value will be the exact location to your vertex. And then just find 2 more points, and there's your parabola. This is huge. If you really understand this and your graphs are beautiful, I mean, minor little mistakes here and there, but ultimately, if you can kind of follow along from these 2 videos, just you are ready for Integrated Math 3. All right. Awesome job, everybody. Awesome. Okay, let me get this loaded.